Hi everyone, it's a bit late in the day for the kind of talk I had in mind, which was supposed to be a bit mathematically intense, so I'll try to keep things light. So I think I should begin by saying that, I'm not interested in technology or acceleration or AI as, a philosophical, historical process. My connection to what we might call inhumanism or post-humanism is through what we might call theoretical inhumanism, which is I guess is actually Pitt Wolfendale and Rizvan Negrestani described it. Essentially just the idea that some processes that are not biological in nature have enough of an affinity to processes of biological intelligence that drawing comparisons and contrasts and looking at relations and analogy can be productive. So this is a viewpoint from which we might think about humans and machine learning algorithms together, or about human conversation and proof-theoretic principles in mathematics together, in much the same way in which a cognitive neuroscientist might be thinking about human brains and the brains of mice together, or human brains and the brains of zebrafish together. So the idea that we have cousins and nieces and nephews, not only in the animal kingdom, but also in the kingdom of mathematical and algorithmic processes. So my research really tries to look at certain AI processes that we already have around, not as technologies, but rather as mathematical empirical objects, such that by considering the fact that these mathematical empirical objects are manifestly possible, they're here, they're working in a certain way, we might revise some of our ideas about what things are possible or impossible in human cognition, and more specifically in the case of my work, about what claims about feats of human cognition or about feats of thinking associated with art, and with the claim specifically of high romantic, high symbolist, high modernist and avant-garde art to a kind of knowledge of a more fundamental stratum of reality than the stratum of perceptual objects in everyday life, and to bring about this kind of knowledge of a deeper stratum of reality through pure cognitive affective intellection of aesthetic structure as such. I mean, if anyone here is engaged with whether it's Shelley or Eliot or any of the manifestos of Dadaism, Futurism and so forth, I feel one must be familiar with a certain romantic to avant-garde discourse of art as a bringer of knowledge of the world that is both inherently unparaphrasable, inherently aesthetic, inherently contained in the form of the work of art as such and not in anything else, but at the same time it's not merely aesthetic knowledge, it's knowledge about the reality behind reality. It's knowledge about the very structure of the world, the way that the symbolist manifesto phrased it, it's knowledge of the affinity of perceptual surfaces to the primordial ideals that animate the life world. So I'm going to be making the case that these sort of, and obviously making a little bit a generic mixture here. Obviously there are differences between high romantic theory of aesthetic insight and high modernist and avant-garde theory of aesthetic insight, but I think you can bring it all a bit bring it all a bit together into a kind of sensualist Platonism or Platonist sensualism, where the very thing that is given to us in the texture and feel, and to use my favorite term, vibe of the work of art, the thing that's most concrete is also the thing that is most abstract about the world as about the real world, the actual world, the life world, as the life world is revealed to us through the work of art. So this is sort of like how should I say, like dyad of the sensuality of the work of art and the sort of like deep structural, almost like Platonist like insight into the world and into sort of like the really infrastructure of the world, or into the infrastructure of experience and cognition, transcendental subjectivity. So once I making this claim for art, it's sort of like a generic romantic to avant-garde commitment. That's the thing that the whole like project of either high art or sort of like radical high art or like aestheticist like high art, since romanticism will like stand and fall on. And I would like to make the case that this claim, which I would say is sort of like, in many ways looking like to be in like increasingly bad shape throughout the sort of like the mid-20th century, at least in the sense that one found oneself like appealing increasingly to like, I don't know, to a kind of like ineffability, the kind of like intrinsic eroticism of the work of art, and so forth. And this kind of like line of thinking that like, we sort of like, we can preserve best the idea that like art gives like a special kind of knowledge by sort of defending this knowledge from like entanglement with materialism, really either in like the Marxist sense or the techno-scientific sense, but sort of like, saying, oh, there's like the kind of like knowledge given to us, by reading Gertrude Stein or by, listening to like free jazz music or, looking at like minimalist conceptual art, it's its own order of knowledge, removed from any other order of knowledge. This sort of like suffered like a Bourdieusian like death blow in the I think started from the 70s. And so the claim I'm going to make is that the resources to reclaim or to make sort of like a case for this kind of knowledge, like fully integrates it into our other aspects of our understanding of what like knowledge is, what thinking is, what society is, even what experience is. These tools are sort of like actually being given to us like right now by the more theoretical aspects of machine learning and by certain like experimental results in machine learning. We don't necessarily have like fully robust theoretical explanations for, but nevertheless are observed. So the claim that I'm going to be making, or I guess the claim that I'm making right now, is that as empirical mathematical objects, this is to say, as objects to like observe empirically rather than have full mathematical theory of, but nevertheless as objects that are purely mathematical objects that demonstrate a purely mathematical truth, certain machine learning algorithms, and in particular the algorithms that I will be talking about, namely autoencoders and other forms of, if anyone here is like a technical machine learning person, you'll at some point notice they use autoencoders in a somewhat broad sense, referring to all unsupervised learning algorithms that involve an element of either generative modeling or dimensionality reduction. But let's set it aside. So I'm going to be making the case that like, by just like looking at what autoencoders are and thinking about like how they work and how one would like to characterize this kind of like knowledge and the way in which it's like achieved, is to say the way in which like autoencoders come to know the things that they learn, we'll find ourselves recreating sort of like naturally much of like the language that the modernist, symbolist, avant-garde industrial complex has created to talk about the kind of knowledge that can only be created, transmitted, and encoded through the creation of like art of this sort of like abstract or pretentious or like weird or like ambient variety. Okay, so what is an autoencoder? I'll start with a little bit of visualization. Okay, so these are just input images. So an autoencoder is what we call an unsupervised learning algorithm. That is to say, when you give it data, it's not trying to learn anything specific about the data. It's not trying to answer any specific questions or make any particular predictions. Rather, we just say it tries to sort of get what the deal with this data is. It tries to find some kind of internal structure, internal logic. It tries to sort of learn how it can sort of generalize the data in the sense of, okay, so I've seen like a million examples of like faces. Can extrapolate for that what like faces they haven't seen look like. And it turns out this problem of given like a million images of faces, sort of like learn a space, learn what we might call like face space, learn the space that contains all and only images of faces as opposed to other images. That is, at least under certain conditions, formally equivalent to learning a kind of conceptual scheme or compression scheme for representing faces. And that turns out, again, under certain conditions, to be mathematically equivalent to learning a method to give an image of a face, push the image of a face through an information bottleneck, that is to say, push it through sort of like a part of like the code that allows far less information to go through than the amount of information directly contained in the image. So if the image, let's say, is like like 1,000 pixels by 1,000 pixels, so the image essentially would be like a list of like a million like numbers, each number representing a pixel intensity. We say, well, actually the autoencoder is gonna only be able to pass 10 numbers to the next stage instead of like passing a million numbers, right? Or like a million numbers is what's required for like the ordinary representation of this image. That's a million pixels. So instead, you can only pass like 10 numbers, and then you're going to have to try and reconstruct the image from these 10 numbers that you could choose however you want, pass on to your like future self, and then try to reconstruct the image. So, as I was saying, so there's a partial equivalence between the problem of learning given like a large data set of images, learning to model image space in general. That is to say, learning to like generate new images that are also images of faces, and learning to tell what is an image of a face and what isn't an image of a face. So between that and the problem of learning the kind of good conceptual scheme for describing images, such that, for example, if I give the autoencoder this face, this face and this face, it will sort of like have like an intelligent understanding of how these faces are, similar to each other and like different than one another, sort of like within the framework of what faces are and what are their like respective variations that characterize faces relative to one another. And that's like an important point, right? Because like think, when you look at a face, you see a face sort of like relative to the space of possibility of like faces. When you look at a face, you compare it to other faces. You don't like compare it to like, I don't know, a cabinet, a wall, a fern. A face is seen relative to like other faces. And when you compare two faces, you compare them to one another, not just like as sort of like, bunches of like pixels, but as sort of like, positions within the space of possibility for faces. So that's like the second task, right? Like typical of unsupervised learning, the task of learning sort of like a good representation or a good like descriptive framework for faces, such that when you compare the description of this face and the description of this face, you immediately get like insight. You're immediately going to be able to do like further reasoning or further learning like easily because you have a good descriptive language or a good conceptual scheme. And lastly, the problem of reconstruction through a bottleneck. That is to say, this takes like 1 million pixels, but you need to like be able to like sort of like write down what the essence of this picture is, using only like 10 numbers and then be able to reconstruct it. So an autoencoder is a system that sort of like solves the first two problems. They just say the problem of like, given a bunch of pictures of faces, learn what a picture of face in general is and become able to generate new pictures of faces, and the problem of learn, a good, like, insightful representation of faces, such as sort of like further cognition about faces will now become sort of like natural and easy because you have a good natural representation. It solves those two problems by sort of like brute force, machine learning, like training, to solve the third problem, which is the problem of reconstruction through like a bottleneck. And that's because when you construct a bottleneck, well, you can't save all the information. I mean, obviously, if all the information is like a million numbers, and you're only allowed 10 numbers as well, so you can't reconstruct exactly, but well, what you can do is like try to like maybe make each number capture, some sort of like structural property of what this face is like, such that when you consider all these like structural properties like together, you get a pretty good idea of what the face is, and can use these sort of like hints and like indicators to like reconstruct the face if you've sort of like learned what like face gestalt is, or like really came to understand what a face is. And so in learning to make this reconstruction through like a bottleneck, another encoder learns a good like intelligent representation for faces. But that's like the only way you can reconstruct is if you sort of like learn like so an effective short representation has to be an intelligent representation, and so in solving the problem of a short representation that allows reconstruction, you implicitly solve the problem of intelligent representation. And then this also implicitly solves the problem of generalization generation, is to say the problem of like from given like a few million faces, learn to generate like random like new faces, and I'm not going to be able to like directly prove or explain like how it does it, but a good nice intuition is that you can think of the set of all images of faces within the larger set of the set of all images in general, and by all images in general, I don't just mean images of actual things. I mean also like any kind of like white noise, or basically any bunch of like pixels you can imagine. That's the space of images in general. Within the space of images in general, the space of images that are images of like faces looks something a little bit like this. Like so, the space of images in general is like whatever, like million dimensional, and the space of like faces would be like 20 dimensional or something. This is like a lower dimensional, visualization for your intuition. So it turns out that something like face space, again, the space of all, lists of pixels that represent a human face within the space of all lists of pixels in general. It's sort of like, like a thin, twisty like ribbon. It's a little bit like a rhythmic gymnast, like twirling ribbon. And as it turns out, the list of, the list of like 10 numbers that you're like allowed to like send to yourself in order to reconstruct a face is often like best understood. That's not true in every autoencoder, but it's true in most of them, as a kind of like internal map on this surface. So let's say that that this whole space is like a million dimension, but this space, you can see it's flat. It will only have like 10 dimensions. So the list, it turns out like the thing like the best list to pass on to yourself is basically a coordinate system for this like surface, such that sort of like the list of 10 numbers that reconstructs, let's say this face. What it really means is that it's basically a coordinate to the point on the surface that is the point where this image is located, right? Because every image of a face is like located someplace on this surface. So a good way to like interpret conceptually and in many cases mathematically what the sort of like most efficient like short code for an image is, and also why is it that this like short code is sort of like acts not just as a compressed representation but as an intelligent representation. That this short code is really like it tells you where in phase space that particular face is located. And as I said, I feel like intuitively when we talk about a face, you understand a face relative to like other faces. So this gives you the intuition that if you understand where a face is relative to other faces within phase space, right, you want to understand where it is within the coordinate system that's intrinsic to the surface, not the coordinate system of all possible gibberish pictures. You sort of like have like a deep structural representation of the face by representing it in terms that are equivalent to like locating it within the space that's like the space of like the systemic gestalt of faces as such. How much time do I have left? Do I have 15 minutes left?
You've been speaking for 21 minutes.
So I think I have exactly 15 minutes left. So here you can look at like two kind of reconstructions that an autoencoder produces. As you can see, so they're a little blurry, but let's not focus on that. Let's focus more in the way that. So this is a dataset known as like Celeb A. It's like many pictures of like minor and major celebrities. And the funny thing you can notice is that the reconstructions look more like celebrities like than the original, or like look more like celebrity than the original. So everybody gets beautified because an autoencoder trained on Celeb A, which is like a few million like images of like facial celebrities, learns to see things sort of like relative to like not just any face space, but sort of like this face of like celebrity faces. And when it tries to reconstruct, it reconstructs sort of like it only reconstructs sort of like those details that would distinguish one prototypical celebrity from another prototypical celebrity. It doesn't reconstruct in terms of the detail that like distinguish an actual celebrity from a prototypical celebrity, right? So like everything here is like perfectly prototypical, and it can only sort of like perceive like differences, and as much as these differences don't bring you even like a little bit outside the sort of like vibe or consistency of like what a celebrity face is like. Whereas sort of like differences, sort of like what you might think of as like the material access of actual celebrity faces that sort of like escapes the gestalt of like the celebrity face as such. That's what gets erased. Here's what I want to say about how this gives us like a work of art, or how this like relates to the idea of the work of art. You're gonna have to like grant me one thing. Sorry, wait one moment. Okay. So one thing you're going to have to grant me is that I'm going to pretend that when we read, Kafka's like The Trial, we've gone past the stage of like dealing directly with words. We've done some kind of like pre-processing or entity extraction, and now the trial in our head, before aesthetic cognition as such, is like an imaginative landscape composed of like events, people, situation. And the same when it's like, if you're reading like Waiting for Godot, let's say we've gone past the stage of like words and we're at the stage in which like you perceive like Waiting for Godot as like a data set made of like, speech acts between Vladimir and Estragon, or like, if you're reading, Gerhard Stein's like Tender Buttons, maybe, you actually do think about it as like a database of actual like, language objects. Anyway, what I'm going to ask you to grant me is that we can transition from a literary text or a film or any kind of like work of art into something that's still prior to aesthetic processing as such, but a little later in the cognitive process, where the book has turned, or the work has turned in your mind into, a collection of entities of some kind, what I call the imaginative landscape associated with a work of art. Okay, so I'm going to argue that the sort of like autoencoder model, and if we think that what we do when we cognize a modernist work of art or modernist work of literature is similar to what an autoencoder does when you give it, like a million images of like faces, and it tries to just like, learn to understand these like objects relative to one another, learn to understand them within like the space of sort of like, logically possible but not actually possible objects, tries to learn like an intelligent representation for them. So what we do, when we read like Waiting for Godot or like back to the trilogy, it's like, well, all of these entities, all these imaginative entities have been like laid before us, and we just want to like learn to like understand them structurally as themselves, and then by doing this we somehow like also learn a way of looking at the world outside the work of art. So I'm going to say that like this way of looking on this work of art like unifies three really important historical and contemporary ideas about what is the sort of like obscure object of like modernist romantic like symbolist like knowledge. And the first like paradigm I'm going to say the autoencoder like viewpoint can sort of like help explain and unify with the others. It's sort of like cultural phenomenological approach that says that like modernist works are like portraits of like moods or like subject positions, or to use the Heideggerian term like Stimmungen, which I'm going to identify with like a subject's like cognitive representation space with like a subject's organon or conceptual scheme. This is a viewpoint that's very active today in literary studies. You can, closely studied with affect studies like Florian Berlantz, Ian Nye. So this is like the first viewpoint, the viewpoint that says a modernist works aims to demonstrate a way of looking at the world or like a subject position. The second viewpoint is sort of like formalist materialist approach that says that like a modernist work is a kind of aggregation of textual or cultural materials that together form some kind of like weak field of coherence or like affinity or like gravity or tension between them. It's like the modernist work is sort of like collage or like bricolage of cultural matter that resonates. And this is closely tied like in literature, like people like Tan Lin and like Hugh Kenner and everyone coming from like more of an artificial context is probably very familiar with this idea of like, the modernist urge just like, to aggregate and resonate. And the last part I'm going to say this unifies is like this sort of like high symbolist, high romantic idea that like a literary text or a literary work like invokes the correspondences, to use the Baudelaire term, or like the esoteric affinities that structure the perceptible surfaces of the world in accordance with primordial ideals that govern the ordinary world of visible phenomena. And this is really like, like the OG, like modernist, like symbolist, like story. You can find it like in Baudelaire, you can find it in Stein, you can find it like Shelley. So I'm going to say that like the idea that what we learn is an autoencoder manifold is something that can bring all these like different like ways of like looking at the modernist like work together. So is this self-explanatory at this point, or like? I'm going to say a few things. So in a way, C, the third one is like the most like obvious, because so imagine it's like so this is like the space of like this is the space of faces as the autoencoder like learned it, right? Or perhaps like this is like the space of sort of like 20th century experience, or sort of like the world as like experienced by like the subject of modernity as you're like learning from like reading like all of Kafka's corpus or something, right? There's like a certain like range of like possible constellations of situations and experiences. It doesn't include all logically possible constellations of experiences. It only includes sort of like Kafkan one might even say Kafkaesque ones. But it seems like once you sort of like learn this like Kafkan like state space, the space of all possible situations that could sort of like exist within like a Kafkan mode of existence, or within sort of like a Kafkan like mode of perception. You also learn to really like understand like internal structure, and perhaps like actually like in your mind you learn a sort of like a coordinate system that allows you to like read Kafka or experience Kafkaesque things in the world, not just to perceive oh this is Kafkaesque, but rather like you know exactly where you are in like this state space of like Kafkaesque situations or Kafkaesque predicaments or Kafkaesque ways of like being. So one thing that's sort of like that the coordinate, that is to say the encoded properties from which one reconstructs the object and which act as like a map of the like internal space of the phenomenon or the state space, or there's sort of like the Platon, in Plato's cave you have like the objects that throw the shadows of the wall on the wall. So the actual like visible surface of like the work of art, even the imaginative one, even just like all the Kafkaesque situations that you experience in imaginable reading Kafka, they're like the mere phenomenon. The noumenon is this sort of like coordinate system underlying like the geometry. Then, when it comes to sort of like the affinity of like the detritus of things, with the weak affinity of them, there's sort of like heap of broken images I've shored against my ruins, or like Ulysses, like the joy of like all the materials of like doubling, like sticking together in their like doublingness. That comes from like the very fact that all the objects of like the objects that we find like in Ulysses, like as we read it. Or also like like the language objects, the language happenings in like tender buttons, or all like the speech acts in Waiting for Godot. We might think that they can all be like represented like using the same sort of like generative systems that makes use of just like like 10 numbers. So it's like there's like a compressed code for like all of these things. This means like mathematically they have property of what we would call like, they're co-compressible, they're jointly compressible. I think that's like a principle of affinity that's like distinct from similarity, but is extremely powerful. I have like a set of things that they can all be compressed like, together like very efficiently. And if you do some other things that don't belong, then the compression quality would like drastically deteriorate. So you want to, suggest that like co-compressibility is a very powerful form of affinity that's different from similarity, but nevertheless is a way in which things belong together. And then lastly, there's sort of like the more contemporary popular perspective of like, the work of art is like a kind of subjectivity, it's a kind of way of seeing, maybe it's like maybe it's even like an ideology, maybe it's about what material access your representations of the world cut away from the world, maybe it's what your way of seeing marginalizes, what it makes invisible, what can see, what in turning the world into a system, into a gestalt, what material access is being like excised. So here's something, like phase space is never actually, even phase space is never actually going to be a true sort of like lower dimensional manifold. What it's actually going to be is a cloud of points that's fairly close to like a manifold, but it's actually going to be a cloud of points around the surface rather than the surface. I mean, that would be true phase space, the actual like space of like, all like the images, but the autoencoder doesn't learn the cloud. The autoencoder learns, the flat surface that's sort of like at the center of the cloud, but the flat surface like flattens. It's like, what it does is like, it projects, right? So this, for example, so like you get this image, and what like happens, like what the autoencoder does is this image would be, let's say, like here, and it projects it to the point in the surface that's closest to it, so it like projects it here, and then it sort of like checks what the coordinates are, and like puts it through like the reconstruction, and you get this, right? So this is like the point that's actually on the surface, whereas this is the point that's in the cloud, like around the surface. So that's like an autoencoder isn't just sort of like proof of compressibility. It isn't just sort of like a structural like model or intelligent representation. It's also a method of like, disclosing and foreclosing. The price of like intelligent representation and the price of finding like a harmony and coherence in the structure is that the material like excess that's literally actually mathematically orthogonal to the structure, all differences that can be understood in terms of the system of differences particular to the space. They disappear from view. I wouldn't say this relates very closely, not only to modern discourse about ideology, systematization, the erasure of the material and so forth, but also to sort of the original sort of Heideggerian formulation of Stimmung or mood as that which is prior to the possibility of thought, or it's the thing that structures what you can and can't think about, and what you can and can't form intentions about. It's actually the level of what's representable to you, and how the things being represented are organized relative to each other. But also just it deals exactly in what information actually makes past your filter. So Heidegger says it's the system that disclosing and foreclosing aspects of the world. And they want to say it's what you learn when you engage with a work of art, sort of modernist, symbolist, avant-garde kind, is by engaging with the work of art, you learn an autoencoder, and that the work of art itself, actually, the work of art, I want to say, is not a cloud of points. The work of art is itself a surface derived from a cloud of points in the real world. And I have a proof that they did with my mathematician advisor that shows that if the work of art is an actual surface rather than a cloud of points around the surface, you could learn from it much more effectively than from the world. So you can learn about the world more effectively from the work of art than from the world. But in learning about the world, or in learning to see the world, you also learn to unsee the world. And thank you very much, and sorry for going over time.